So we're going to look at geometry, and the first things in geometry that we need to do is define some vocabulary. So first thing, the very most central part of geometry is a point, and that is an exact location in space somewhere with no shape or size. So it could be really big, it could be really small. We usually see it as a dot, and we label it with a capital letter. So my illustration is a dot with the capital letter X, and we say point X, or we say capital letter X. Make sure it is a capital. Then, if we have a bunch of points lined up really closely together and they are touching, we can say it's a line. A line is an object with no thickness that extends infinitely in two directions. So, we've got a line, it's got arrows on both sides. We name lines by a cursive letter or by 2 points. And again, remember those points are capital letters. So when we name it, we can say line M, or we can say AB. We can also say BA, and we want to make sure it's a line, so we put a symbol for a line up above it. Next definition is a line segment, which is a part of a line consisting of two endpoints and all the points in between. So that means we're taking a piece of a line, it has a beginning and it has an end. And so this notation, when we name it, we say from one point to another, we put a mini line segment up above, and the order of the points doesn't matter. So this line segment could be CD or DC. Next piece is a ray, so part of a line with one endpoint, and it extends infinitely in one direction. So a line extends infinitely in two directions, a ray only extends in one direction. So you can think about that as though it were from the sun. And so your sun, you've got that big glowing thing in the middle, and then all the rays are extending only in one direction. It's not extending inward on itself. When we name rays, order does matter. We always want to write the endpoint first. So we would say EF, and we show that it's the endpoint by having technically the point above the E and the arrow above the F. So technically we could write it backwards as long as the symbol on top was correct. It just looks kind of funny that way. Next, we've got opposite rays. So they are rays that share a common endpoint, but continue infinitely in opposite directions. So if you'll watch me draw it, we've got a ray here, and it's going to the left, it's extending to the left, and on the right side, it's extending to the right. So basically, it looks like a line. We'll put 3 points on there. And we can name it a lot of different ways. We could say XY as long as we have the line symbol above it. We could say YZ as long as it has a line symbol above it. We could say XZ as long as it has a line symbol above it. But since we are naming rays, we'll say XY and we'll say YZ. Make sure your ray is pointing in the right direction and know that they make a line, but here we're talking about opposite rays, so we'll name the rays. Next thing we have is a plane, and that is a flat surface that continues infinitely in all directions. So it's continuing forever to the left, to the right, bottom, top, going everywhere. When we draw it in geometry, we use a parallelogram. The cool thing about planes is that you can have points in there, you can have lines in there, you can have rays in there. And when we name it, this is another place where we have a capital cursive letter. Lines have a lowercase letter. Planes have a capital cursive letter. And so here we would say plane G, or we can name it with at least 3 points. Let me add another one in there. And we can say plane A, B, C. Last 2 vocabulary words, we've got collinear and non-collinear. So collinear, co means together. So those would be points that lie on the same line. So if we have a line, we would say that J, K, and L are collinear. And we would say M up here is not. So we would say non-collinear. So then we've got coplanar and non-coplanar, so points that lie in the same plane. So we would say T, U, and V are coplanar. We would say W is non-coplanar. So then if we kind of put it all together, using the vocabulary and using our illustrations and using how we name things, we have a bunch of stuff in a plane. So we're going to kind of work through this. Number 1 says give 3 names for the line that contains point A. So first thing we need to do is find point A. It's right here. It is on this line. So I notice that it has this fancy L. So 1, we know that it's on line L. And then if we look back, we know that we can name a line by 2 points. So we can pick any 2 points on that line. So we could say AC. Make sure you've got the symbol above it. We could also say BC. We could say AB, we could say BA, we could say them in any order. So there's lots of choices there, but there's at least 3. So then number 2 says name a point not on line L or line M. So line L is here, line M is here. So the only 2 points that I have that aren't on those 2 lines would be point E and point F. So it just says to name 1, but we can name them both just for fun. Number 3 says to name 2 line segments. So by definition, a line segment is a part of a line that has endpoints. So if you look at your lines in here, they all have arrows. But we know that we can name them correctly as long as we have 2 endpoints and we put a line segment up above them instead of the arrows. So 2 line segments, we could say AC, we could say BD, we could say DF, we could say BC, we could say BE, we could say a lot of things as long as the notation is correct. Number 4 says name a ray, so it's extending in one direction, not contained within a line. So that means there are no opposite rays, they're not butted up against each other, it's just a ray going in one direction. So we've got 2 actually, we've got BE and DE. Remember, when we name them, we start with the endpoint. And make sure that your ray up above is mimicking where it starts and where it continues on forever. And then finally, name the plane that contains lines L and M. Well, the plane is plane P. And we just use the letter P. So if we continue practicing, a couple of things. If we have segments, we know that if we have a small segment and it's butted up against another small segment, they make a big segment together. So little plus little equals big. With geometry, it's very, very important that you draw as many pictures as you can. It helps you understand what questions are asking. So segment addition postulate, that means that it's always true, a postulate. It can't be proven wrong. By definition, it says given 2 points A and C, a third point B lies on line segment AC if and only if A plus B plus B plus AB plus BC equals AC. So those are all line segments. So first thing, we've got 2 points, A and C. And we know that B is somewhere between them. And what we're saying is that this line segment here combined with this line segment here equals the whole thing. So beginning is A, end is C. AB plus BC equals AC. My little piece plus my little piece equals the big piece. So we'll run through an example. So if C is between D and E, so we'll pause there and write it. So C is between D and E. We find that DC is 2x plus 3, and CE is 3x plus 1, and DE, so this whole thing, is 44. According to my segment addition postulate, we know that my two little pieces equal the big piece. So one little piece is 2x plus 3. The other little piece is 3x plus 1, and it equals the big piece, which is 44. All we have to do from there is solve that equation. So we'll combine like terms, and then we'll solve. Hopefully you're really comfortable with solving equations. I'm not going to run through all the steps there. In the end, we find that x is 8. If we look back at our original problem, it doesn't say what is x. It says find DC and find CE. So those are technically line segments, so we'll make sure that notation is right. And so if DC is 2x plus 3, we're going to take that equation and plug in an 8 for x. So then we have 2 times 8 plus 3, which is 19. And then CE is 3x plus 1, and we know that x is 8, so we'll plug it in. And we find that it is 25. And so those would be my answers for that question. So if we look at a second example, if B is between A and C, and AB is 4x plus 6, and BC is 7x plus 15, and AC is 120, find AB and BC. So first thing we want to do is draw our picture. So we know that B is between A and C. That's nice when it's alphabetical. AB is 4x plus 6. BC is 7x plus 15, and the whole thing is 120. So using what we know, we'll say little plus little equals big. So my little piece is 4x plus 6. My other little piece is 7x plus 15. And my big piece is 120. So we'll have combine like terms and solve. Again, I'm not going to run through those steps. I'm hoping that you are really comfortable with solving and don't need that extra reinforcement there. So we end up with x equal to 9. To solve it, we would plug our x value back in and find AB and BC. So AB was 4x plus 6, so now I have 4 times 9 plus 6. So I've got 36 and 6, which gives me 42. And from there, what I really could do is subtract it from 120 and find whatever's left. But we'll make sure to plug it in just for the practice. So 7 times 9 plus 15. So we have 7 times 9 is 63, plus 15 should be 78. And so those are my answers there. And you can check, so add them together, does it equal 120? It does. So next thing that we'll look at, similar but not exactly the same, is the segment bisector. A segment bisector is a line, ray, or segment that divides another line segment into two equal parts. So that two equal parts is the most important thing because it's actually your definition for bisector. So here we'll have a segment and it is being bisected by something. It doesn't matter if it's a ray, it doesn't matter if it's another line segment. It's just being bisected. But the special part about that bisector, it's saying that these two pieces are congruent. And so to show that those two sides are congruent, we use these special little tick marks. You can have one of them, two of them, three of them, four of them, whatever, just to show that these two pieces right here are congruent. I'm going to go ahead and label our points so we can then write a true statement. So we've got points A, B, and C. And so if B, that point, is the middle of AC, we can then say that line segment AB is congruent to line segment BC. So we'll work through a couple of examples. EF bisects AD, so AD is cut into two equal parts by line segment EF. So we'll draw AD is bisected by EF, which means that we need to show that these two pieces are equal. And it says that the point that it's bisected at is C. Then it tells me that AC is 5x minus 8 and CD is 16 minus 3x. So if those two pieces are equal, to solve for x, all I have to do is set those pieces equal to each other. And then it's just a regular equation that we've seen before. So I'll go ahead and solve that. You can pause it and work it. Make sure you can solve equations. And we find that x is 3. To finish solving it, we would have to plug that x value into both of these and add them together. We could just find one side, knowing that the other side is equal, and add them together. Either way, you know how to plug it in and solve for AD, so I'm going to skip that in the video. Well, I'm just not going to write it out, but I'll talk you through it. So let's plug in our 3 for x. So 5 times 3 is 15. 15 minus 8 is 7. To make sure that we did it correctly, we can check the other side. So 16 minus 3 times 3, so 16 minus 9 is 7. Both sides are 7, so we know that together they give me 14. Next, we've got GH bisects JK at I, so JK is cut in half at a point I. Make sure you can draw it. Since it was bisected, we do have to show that those two pieces are equal. And we know that JI is 2/3 of 4.5x minus 1.5. So we're getting kind of crazy there with those fractions and decimals. And that IK is 12 minus x. I ran out of room. So we know in order to solve them, we would set them equal to each other. All we're going to do on this one is set it up, knowing that we would solve, find x, and then plug it back in to get JK. If you need help, let me know, and then we can work it out from there. But just for time, we're just going to set it up. Last thing we're going to talk about is the midpoint of a second. So it's similar to a segment bisector, but now the thing that is dividing a segment into two equal pieces is now a point instead of some sort of line. So midpoint of a segment is a point on a line segment that divides it into two equal segments, the halfway point of a line segment. So it's kind of redundant. So let's make a line segment We'll say A and B, and we'll say X is the midpoint. If it's the midpoint, that means that AX and XB are equal. They're congruent because it's the middle. X is the same distance from A that it is from B. So again, really similar to your segment bisector. And then we'll work through a couple of examples. So M is the midpoint of PQ, so we want to draw that out first. PM is 9x plus 3. MQ is 11x minus 17. Since it is the midpoint, we know that these two pieces are equal. So then it says to find X and PQ. So since they're equal, we'll set them equal to each other. At this point, we only know two things. We either know to set things equal to each other or do little plus little equals big. So in this case, if you get stuck, if you don't know what little plus little equals big, we don't know what the big piece is, then set them equal. And then solve. So we find that X is 10. So we found one piece of the information, so X is 10, so we'll plug it back in to find PQ. PQ is the big piece, so we'll have to plug it into both sides and add them together. So PQ, we've got 9 times 10 is 90, plus 3 is 93, so we'll make sure it's the same on the other side. So 10 times 11 is 110, minus 17 is 93. So we know that we did that part correctly because they're equal. And then we'll have 93 plus 93. So I believe that is 186. And so we've answered all that information. So we'll go ahead and set up everything on the next one, and I'll leave you to solve it. M is the midpoint of PQ, so it'll be a really similar picture. Since it's the midpoint, you want to make sure that you show that they are equal. It's easy to forget that part. PM is 5x plus 8, and PQ is 76. So now we don't know the other side. It doesn't tell us the other side. But because we're smart and know that M is the midpoint, and midpoint means it's equidistant from both of those sides, what do we know, or what should we know about MQ? Well, since this side is 5x plus 8, we know that this side is also going to be 5x plus 8. So we're kind of combining segment addition postulate and our midpoint of a segment. So now we know little piece plus little piece equals big piece. So we'll say little piece plus little piece equals my big piece. Combine like terms and solve. So now we find that X is 6, PM is 5x plus 8, so we'll plug the 6 back in. So 5 times 6 is 30, 30 plus 8 is 38.